Good morning, year 11. We've decided that we are going to talk about sequences today because we revised it in class. And yes, I think you are doing really well in class. And then if we revise it a little bit more, look through some questions that have been given in previous years, then it will consolidate and you will remember how it's done whilst you are in your own exam. So every single sequence is connected to classic one, to a similar one. For example, you know your times tables. So 3n. Yes, the simple way of writing 3n down is 3, 6, 9, and whatever, 12, and we keep going. We call this the first term, the second term, the third term of the sequence, the fourth, and so on. And this number here is our n, this n, okay? So 3n, 3 times 1 is 3. So 3n means you triple the position and get the value of the term. And this is for 3n, this is the 3 times table. But what if I write a sequence as 5, okay, and then 8, write 11, 14, and so on. You see, now the first term is 5, the second term is 8, the third term is 11. What is similar between these sequences is that each time we go to the next term, we add 3. They both have the same gap. This is how we recognize this is a 3n sequence, a little bit modified 3n sequence. Okay, how was it modified? What did we do to get from 3, 6, 9, 12 to 5, 8, 11, 14? We shifted a little bit on the number line, okay? What did we do? We added 2. Yes, so from 3n, we started a little bit later on the number line. That sequence will be 3n plus 2. Okay, so how do we do it? What do we do to find out? For example, we are given 7, 12, 17, 22, and so on. So our sequence is 7, 12, 17, 22. That's our first term, the second term, and so on. The gap between terms is 5. So we go up in 5, plus 5 each time, okay? Plus 5, plus 5. This means this is a 5n sequence. This is related to 5n. Then, okay, let's put the 5n sequence down. So this is our 5n sequence. 5, 10, 15, 20, and so on. And from 5n, what do I do? How did I shift the 5n sequence to get to 7, 12, 17, 22? I just added 2. So this one here will be 5n plus 2. Okay, right. But if 5n is the formula for this sequence, position to term rule, okay, or the nth term, what will be the 50th term? So the 50th term means n is 50 because that's the 50th. N means n is the position of the term, so n is 50 because we are trying to find the 50th term. So for 5n, okay, the term, the 50th term will be 50 times 5, which is, let me write it down here, okay, which is 250. So the 50th term of this sequence, the purple sequence, will be 250. This is our classic 5 times table. What about the other sequence? The other sequence is plus 2. So it's a little bit shifted. It will be 5n plus 2. So we do 5 times 50 plus 2. So instead of 250, it's going to be 252. Okay, what about, let me give you another sequence, for example, 3, 11, 19, 27. What do we look at the beginning? The gap. So what did I do? I added 8 all the time, every time, add 8. So this is definitely a 8n sequence. Okay, let me write the 8n sequence down. Okay, that will be 8, 16, 24, and then 32, and so on, okay? Don't forget, these sequences can continue over and over again, or you can stop. You can have a finite sequence or an infinite sequence. Right, what do we do now? How did I shift from 8, 16, 24, 32 to 3, 11, 19, 27? What did I do? I just shifted down, if that's possible. So I took away 5. So this one will become 8n minus 5. You see, every single term is minus 5. Okay, I'm going to give you the pleasure to calculate the 50th term for this new sequence. Okay, so the 50th term for the classic sequence, the 8n sequence. Okay, the 50th term is 8 times 50. Okay, 8 times 50. That is 400. Very good. And for 8n minus 5, just take away 5 from 400. Okay, so it will be 400 minus 5. That would be the 50th term for the orange sequence. Yes, that's 395. We've just calculated the 50th term. Okay, now let's look at some questions. Okay, going to look at some questions that have been given in exam. Okay, these are easy questions. Why? Because they, as you can see, they are just 1 mark, each of them. 1 mark for this one, 1 mark for this one. So it shouldn't take you longer than a minute. It might even take you 50 seconds or 30 seconds or 10 seconds. It says find the first 2 terms of this sequence. So the first term and the second term. This means when n is 1 and when n is 2. Okay, when n is 1, n squared is 1 plus 5, that's 6. So the first term is 6. The second term, when n is 2, 2 squared is 2 squared plus 5. 2 squared is 4 plus 5, that's 9. Okay, so the second term is 9. They ask you if is 126 a term of this sequence. Okay, let's try and find out. We are going to write, so if this is a term of this sequence, then we are going to end up with a counting n. Yes, 1, 2, 3, 4, whatever, 50, 30, but never with a decimal. So we cannot end up with a decimal when we solve that equation. And the equation is pretty simple. N squared plus 5, that's 126. Okay, let's take 5 away from both sides and isolate the n as we are used to do. Okay, so n squared will equal 121. I bet you already recognize 121 as being 11 squared. So n is 11, okay? Yes, 126 is a term of this sequence, is the 11th term. So you're going to write here, yes, the 11th term. Okay, so when n is 11, you put here 11 squared, 121, plus 5, 126. Great. Let's go to the next question. Here are the first 5 terms of an arithmetic sequence, 26, 19. Oh, this goes down. When a sequence goes down, okay, decreases, we are going to calculate with minus n. So the coefficient of n will be minus a negative value, okay? Because that's going down. So it's minus 7, minus 7, minus 7, minus 7, you see? Right, so let's put the minus 7 sequence down. So I'm going to write the minus 7n down first. That would be minus 7, minus 14. I keep going down with minus 7, minus 14, minus 21, minus 28, minus 35, and so on. Okay, so I keep going down. Okay, now this is my minus 7n sequence. How did I get from this to that? What did I add it? From minus 7 to 26. Okay, minus 7 plus what? Equals 26. If I add 7, I get to 0. I have to add more. I have to add 26 more to get to 26 on the number line. So it will be 7 and 26 all together. That's 33. So I've added 33 there to get to 26. And here is my mark. So the formula for this sequence will be minus 7n plus 33. Now let's check. Minus 7 times 1 is minus 7. 33 minus 7 is 26. Correct. Okay, let's clear our drawings and let's go to the next one, of course. Here are the first 6 terms of an arithmetic sequence. Find an expression in terms of n for the nth term. Okay, let's find it. First, we go for the gap. It's plus 5. Okay, that's 5n. Let's put it down. 5, 10, 15, 20. Okay, and then from 5n, how do I get to 3, 8, 13? Take away 2. So 5n minus 2. My sequence is 5n minus 2. The nth term of a different sequence is 3n squared. Okay, Nathan says that the fourth term of this sequence is 144. Okay, the fourth term. So what they are checking here is if you know what that means. So when you see the fourth term, it means n is 4. If you see the 100th term, it means n is 100. But we know we don't need n is 100 now, okay? So I'm going to just erase that part, not to confuse you guys. So the fourth, n equals 4. Okay, let's try it. We replace it. Don't forget there are no brackets there, so we start with indices, okay? So what do we have there? We have 3 times n squared, okay? My n squared is 16. So it will be 3 times 16, which obviously is 48. So it says, Nathan says that the fourth term of this sequence is 144. Okay, well, it's not. As you can see here, the fourth term in this sequence is 48. So, of course, Nathan is not right. All right, so let's go to the next question then. Okay, this is a little bit, it looks a little bit difficult, but it's not. You just need to observe the pattern, okay? So you look at each pattern and what do you see? You see that 3 were added on top of it, yes? If you want, you can even count, okay? So the first term is 4, the second term is 7, the third term, if you look, it's 10. Okay, so the gap in between them is 3. That's a 3n sequence. Okay, that's plus 3 each time. A 3n sequence, okay? So let's write the 3n sequence down. 3, 6, 9. Great. How did I get from here to there? 3n plus 1. So this one is 3n plus 1. Amazing. We've done it. 2 marks. 3. Let me write it down. 3n plus 1. And we got our marks. Bayo has 90 counters. Okay, that's good. Can Bayo make a pattern in this sequence using all? I don't know, let's check. Can he have a pattern number whatever with 90? This means is 90 a term in this sequence? Does it fit in this sequence or not? Let's check. So 3n plus 1 is 90, correct. Okay, so 3n must be 89 because 89 plus 9 plus 1 is 90, okay? But when you divide 89 by 3, do you get an integer? Do you get a counting number? No. Let me show you. 89 divide by 3. 3 goes into 8 twice. Remainder 2. 3 goes into 29 9 times. Remainder 2. So we are going to go into the decimals now. So 3 goes into 26 times, remainder 2, and we will keep going like that. That's a recurring number, okay? Right, so no. You cannot make a sequence with 90 counters. I mean, You can make a sequence with 90, but you're going to have one left, okay? And here they say you need to use all 90 of your counters. So definitely you can't use them all because you will have one remainder, okay? So you can write your explanation in any way you want, but the examiner needs to see this written down. Okay. Let's look at this one. The nth term of the sequence is 3n plus 4. Explain why 21 is not a term in this sequence. Okay.